In this video, we're going to learn about the center and radius of a circle in the coordinate plane. So here we've got a problem. Given the points A, 2, 5, and B, 8, 11, the segment AB forms a diameter of the circle. First of all, we want to find the coordinates of the center of the circle. Now remember that the center of the circle, the center is just the midpoint of the diameter. And we have 2 points that form a diameter, so we really just want to find the midpoint of the diameter, which consists of endpoints at A, 2, 5, so midpoint of 2, 5, and the other endpoint is B, 8, 11. Now we can just go ahead and apply the midpoint formula. And the midpoint formula, we get the x-coordinate by adding the 2 x-coordinates of our 2 points and dividing by 2, just taking the average, so 2 plus 8 over 2. And then same thing for the y-coordinates, so 5 plus 11 over 2. Let's go ahead and compute that. So that's equal, 2 plus 8 is 10, so we've got 10 over 2. And then 5 plus 11 is 16, so 16 over 2. And 10 over 2 is just 5. 16 over 2 is 8. So there we go. That is our center of the circle. Next up, we want to find the radius of the circle. And remember that the radius of a circle is just equal to the distance from the center of the circle to the edge of the circle. And we know what the center is, so let's write that again. Distance from the center, we just found that over here, center is 5, 8. So distance from 5, 8 to the edge. So do we know any points on the edge of the circle? Well, the endpoints of the diameter have to be on the edge of the circle, and we know both of those points. We've got A, 2, 5 and B, 8, 11. So we could choose either point for the edge. Why don't we just go ahead and choose B? So B will be 8, 11. And now we just need to compute the distance between these 2 points, which we can do using the distance formula. So distance formula, we just go ahead and subtract the x-coordinates, so 8 minus 5, and square that, and then add the same thing for y. So subtract the y-coordinates, 11 minus 8, and square that. And now we just need to compute this. So square root of 8 minus 5 is 3, so 3 squared, then plus 11 minus 8 is also 3, so 3 squared plus 3 squared. Continuing our computation, this is equal to the square root. 3 squared is 9, so 9 plus 9, which is square root of 18. 18 is just 9 times 2, so this is square root of 9 times square root of 2, and we write it that way because 9 is a perfect square, which means that square root of 9 is a whole number. Square root of 9 is just 3, so 3 root 2. So there we go, that's our radius. Radius is 3 root 2. Next up, let's prove that the point P, 1, 2 lies within the circle whose center is 0, 3 and whose radius is 2. Alright, so we have to prove this, meaning that we have to write a bulletproof explanation. First, we need to explain what it really means for a point to lie within a circle, and then we have to verify that the point P, 1, 2 actually does lie within the circle whose center is 0, 3 and whose radius is 2. So let's start by answering the question, what does it mean for a point to lie within a circle? Well, for a point to lie within a circle, it needs to be within the circle's radius. More precisely, and for this circle in particular, we write that a point lies within a circle of radius 2 if its distance from the center of the circle is less than 2. So in order to conclude that the point P12 lies within the circle, we just need to compute the distance between P12 and the center 0, 3, and then show that that distance is in fact less than 2. So let's go ahead and compute that distance. We'll write down that the distance between our point P12 and the center 0, 3 of the circle is given by the following computation. Let's call it d for distance, and d will have to be equal to the distance between 1, 2 and 0, 3. So we'll need to go ahead and apply the distance formula. So go ahead and subtract the x-coordinates, 0 minus 1, square that, and then do the same thing with the y-coordinates. Subtract those, 3 minus 2, squared, and now we just need to go ahead and compute this. So d is equal to 0 minus 1 is negative 1, so negative 1 squared, then plus 3 minus 2 is 1, so plus 1 squared. So continuing to compute, negative 1 squared is just 1, and then 1 squared is just 1. So d is square root of 1 plus 1, which is square root of 2. Indeed, the distance square root of 2 is less than 2. So now we just need to write that down and state our conclusion. So let's go ahead and do that. We'll write down that because d equals root 2, which is less than 2, it follows that P lies within the circle. So there we go, we're done. So now we know how to compute and write proofs involving the center and radius of a circle in the coordinate plane. In the future, we'll continue doing more coordinate geometry with circles.